Hi guys, so welcome back to the second lesson on stoichiometry, where we will be talking about the mole and also about Avogadro's number. So just in short, as an introduction, I found this very cool infographic online at Compound Chem, and you're more than welcome to go and look at all their infographics because it's really nice. So what is a mole, right? So a mole represents 6.022 times 10 to the power of 23 particles. Okay, so if we had to look at this number here, look at how many zeros and places it has. So it is essentially a very large number. And you can see here it says 1 mole is essentially this amount of something. Okay, so in chemistry, we just refer to it as atoms or molecules or even ions. But where we would refer to 12 eggs as being a dozen of eggs, in this case, we would refer to this 1 mole representing that amount of particles. Okay, so 1 mole is the amount of a substance that contains exactly that amount of atoms, molecules, or ions. Okay, and this is known as Avogadro's number, and it's denoted with an N and with a subscript A. Okay, here you can see on your left hand side, that is Amedeo Avogadro, the scientist that was recognized for this work. Now, if you were to go and compare this number to different substances, you would see that 1 mole is a different mass for different elements and for different compounds. Okay, for example, for 1 mole of water, okay, so that would represent 1 mole of water, and that would be 18.0 grams. So 18 grams of water is 1 mole, okay? 55.9 grams of iron is 1 mole of iron. And the same goes for oxygen. 32 grams of oxygen is considered to be 1 mole, okay? And it's that amount of particles. And so you can see for different elements, you have different grams associated per mole. And that's why on the periodic table, we refer to the relative atomic mass or the molar mass as grams per mole, okay? So a mole is, like I said, often referred to as a chemist's dozen, and it's an easy way to count very large numbers of atoms and molecules. Okay, and then we're going to look at a calculation. To work that out, you will take the mass divided by the mass of 1 mole, the molar mass that you will find on the periodic table. Okay, so we're going to look at those calculations just now. So jumping to a formal definition and a few applications of the mole concept and Avogadro's number. Just as a quick summary, a mole is the amount of substance that contains the same number of elementary units. Okay, and these units refer to atoms or molecules or ions as the number of atoms in exactly 12 grams of carbon. Okay, so in essence, this is the formal definition. But like I said in the previous video, 1 mole of carbon is 12 grams, right? And that is 6.022 times 10 to the 23 particles. Okay, and that's the same for your other compounds, so, or elements rather. So if I said, well, what about sulfur? If I have 1 mole of sulfur, 1 mole of sulfur, and you will see this mass on the periodic table, is 32 grams. Okay, this is just a rounded value, and that is also 6.022 0.022 times 10 to the 23 sulfur atoms. Okay, this is also carbon atoms. Okay, and even if you look at, let's say we look at nitrogen, right? So 1 mole of nitrogen, okay, and if you look at the mass, is 28 grams, and thus it is 6.022 times 10 to the 23 nitrogen. But now look at this. We're talking now about molecules. Okay, because this is a molecule. It's not an element where we then talk about atoms. Remember, it breaks up into its simplest parts. So if you have a molecule, then we refer to that as molecules. But if we want to take this and refer to that as atoms, then you can see that for 1 molecule of nitrogen, there is 2 atoms of elemental nitrogen, right? So if you want to then work out the number of nitrogen atoms, you will just take Avogadro's number and you will times it by 2, and that's going to give you the number of nitrogen atoms. Let me quickly work that out for you. So that will give you 1.20 times 10 to the 24 nitrogen atoms. Okay, and if you have, let's say, you have sodium chloride, and you want to understand that 1 mole of sodium chloride, now this is a tricky question. Remember when we worked out the molar mass? Remember that you would take the separate masses and add them together. So for sodium it's 23, and for chloride it's 35.5. So you can see I'm just using the rounded values for illustrating this idea here. And that would be the grams associated with 1 moles of sodium chloride. And you can now even go and work out if this is the amount of grams of sodium chloride, how many sodium chloride units do you have? Okay, and once again, this is the amount of sodium chloride units that you have, and we also refer to that as formula units. If you want to work out how many sodium ions you have, can you see there's only 1 sodium ion and there's 1 chloride ion. This is a cation, this is an anion. So you take that value and times it by 1 for the amount of sodium, and just times it by 1 for the amount of chloride. Okay, if you had something like, let's say, calcium chloride, you would have that same amount of calcium, but to get the number of chloride ions, you would take Avogadro's number and times it by 2. Okay, so let's look at a quick calculation. If I have a beaker, and inside of my beaker I have an organic salt or compound, so C6H5 chloride. Okay, so if I tell you that this is the compound that you have, and I give you some additional information, I tell you that that's the mass of the organic compound, I want to know how many atoms. So how many atoms do I have inside of this beaker? Okay, and you can now go and calculate that. And this is where I introduce you to the first and the most important formula in stoichiometry. And that is that the moles of a substance is equal to the mass divided by the molecular mass. Okay, so we're going to, first of all, we have the mass, right? So we have the mass. we can get the molecular mass from the periodic table, and then you can go and work out the moles. Okay, so let's quickly do that. Take the mass, and now to work out your molecular mass, remember, you have to add up these different masses on the periodic table separately. So you've got 6 carbons, and the mass of one carbon is 12 grams per mole. Okay, again, I'm just rounding up. I'm not going to be too analytical. Then you have 5 hydrogens, and you have 1 chlorine. Then if you do that calculation, you would work out, let me just rewrite that. You will work out 3.07 moles. Okay, so in that amount of grams of this organic salt, you have that amount of moles. And now that you have your moles, you even go further and say, well, I want to know, remember, before you can go to atoms, you first of all have to work out how many molecules do I have, right? So you're going from this solid, first of all, you calculate the moles, and from the moles you calculate how many molecules do you have, and from the number of molecules you can calculate the number of atoms. Okay, because this is a molecule, we've got covalent bonding in that compound. So to work out the number of molecules, this is where Avogadro's calculation comes into play. So the number of molecules is equal to the mole times Avogadro's number. So the mole is 3.07 and Avogadro's number 6.022 times 10 to the 23. So if you work that out, you get 1.85 times 10 to the 24 molecules. So you can see in this amount of grams, I have a lot of molecules. Now that you have your molecules, you can go and work out how many atoms. Now, if you just look at the structure of your molecule, you have 6 carbons, you have 5 hydrogens, and you have 1 chlorine. So how many atoms is that? 6 plus 5 plus 1, which gives you 12. Okay, so you have 12 atoms in total. Okay, so 12 carbons. So now to finish off your calculation, you will say, well, this is the amount of atoms that I have. So you will now take the amount of molecules and you're going to times that by 12, and that will give you the amount of atoms. So that's 2.22 times 10 to the 25 atoms. So you can actually see that's the amount of atoms that you have inside of your beaker. Okay, so that's pretty cool. Now let's look at another example where I'll be showing a ionic compound. So I have a beaker. Oops. Hate it when that happens. So I have a beaker, and inside of my beaker, okay, I have ammonium carbonate. Okay, now this is what they can actually ask you in the exam, and you need to know what ammonium carbonate looks like. So that what is the formula of that? And they tell you, look, you have 165 grams of that in there, and I would want you to work out how many anions and cations. So you need to determine how many ions first of all. Let me write down the scheme of what you are going to do. So you have your mass, okay, and from your mass you're going to calculate the number of moles, And from your number of moles, you can calculate with Avogadro's number the number of formula units, okay, which is just a fancy name for your total ions. And then from there on, you can go out further and you can calculate, but how many cations do I have and how many anions do I have? Okay, first of all, and very important, what does this thing look like? Ammonium NH4 plus. How do you know that? You need to go study it. Okay, carbonate CO3 2 minus. So if I combine these two formulas together, remember that's 2 will go there and that 1 will go there. So if I write down this formula, NH4 2CO3. That's what ammonium carbonate will look like. Remember, positive charge means this is a cation, negative charge, this is your anion. Okay, so that is your compound. Now we can go further and say, let's calculate this. So for starters, you're going to work out the moles. So the mole is the mass divided by the molar mass. So you have the mass in grams, and the molar mass is what you need to go and calculate. Okay, so you can either do it here or you can do it separate. I'm going to do it separate for this one, just so that you can see nice and clearly where I got my numbers from. So remember that these numbers you get from the periodic table. Nitrogen has a molar mass of 14 and there's 2 of them. How do you know that there's 2 of them? You can see that this 2, this is brackets, right? And this 2 is applicable on that nitrogen and on that hydrogen. So 14 times 2 plus 2 times 4 is 8. So it's 8 times 1 because that's the molar mass of hydrogen. Plus I've got 1 carbon there which has a mass of 12. And I've got 3 oxygens that has a mass of 16. So if I add this up, my total grams per mole is 96. Okay, so that's 96 grams per mole. Okay, if you do your mathematics, you'll see your grams cancel. The negative mole goes above the line. That's why your units end up as being moles. Okay, and how many moles do I have? 1.72 moles. Okay, so that was quite easy. Now we just need to go and calculate how many formula units do I have. So, and this is where you will use Avogadro's number. So formula units will be, take the moles and you times it by Avogadro's number, and you will see that it gives you this as an answer. Okay, and that's the amount of formula units or the total number of ions that I have inside of my beaker. Now, if you could recall from the formula NH4 to carbonate, if you look at the amount of ammonium ions, which is my cations, you will see that there is 2 of them and there's only 1 carbonate. Okay, this is a cation, this is my anion. So to calculate the number of cations in solution or inside of your beaker, okay, this is now basically going to, we're assuming the formula mass unit. Remember that if you dissolve it, then the ions break apart from the structure. But inside of the structure, to get the number of cations, you will take the number of ions and times it by 2. Okay, and that will give you, let me just check my calculation, that's going to give you 2.08 times 10 to the 24, that should be positive cations. So that's a lot. And how many anions? Well, there's only 1 anion carbonate, and you'll just times that with the number of ions, and that will just give you the same number of ions. Okay, so that was in short just some applications to Avogadro's number and also to the concept of what is a mole. I hope it helped. Please stay tuned for more on stoichiometric calculations, because from here on it's going to get even better and more exciting. So hope to see you guys again. Bye.